Activity 7. Conduct an experiment to show that the current drawn from a battery is equal to the sum of individual currents drawn by the bulb in parallel connection. A. To prove that the current drawn from a battery is equal to the sum of individual currents drawn by the bulbs in parallel connection. Materials required: key, conducting wires, ammeter, battery, junction point A, 3 bulbs, 3 ammeters, junction point B, and multimeter. Procedure: connect all the materials as shown here. Switch on the circuit. Current in circuit is dividing into 3 paths at junction point A. Measure the amount of current passing through each path, that is, current passing through each bulb using ammeters, and record the observation as current passing through bulb 1, I1 is equal to 2.7 amperes. Current passing through bulb 2, I2 is equal to 3.1 amperes. Current passing through bulb 3, I3 is equal to 3 amperes. Measure the current drawn from battery using ammeter 1 connected across it and note the reading as I. I is equal to 8.8 amperes. It can be observed that current I drawn from the battery is equal to the sum of currents passing through the bulb 1, 2 and 3, that is I1, I2 and I3 respectively. I1 plus I2 plus I3 is equal to 8.8 amperes, that is equal to I. Measure the potential difference across each bulb using multimeter and record the observations as potential difference across the bulb 1, V1 is equal to 3.0 volts. Potential difference across the bulb 2, V2 is equal to 3.0 volts. Potential difference across the bulb 3, V3 is equal to 3.0 volts. Potential difference across the battery B is equal to 3.0 volts. It is noticed that potential difference across each bulb is same as that of potential difference across the battery. Result: hence, it can be concluded that current drawn from battery is equal to the sum of individual currents drawn by the bulb, and the potential difference across each bulb is same as that of potential difference across the battery in parallel connection. Let us find equivalent resistance of parallel connection. Let us replace all the bulbs with resistors. We know that the potential difference across each resistor is same as they are connected in parallel. According to the Ohm's law, current through resistor R1 is I1 is equal to V by R1. Current through resistor R2 is I2 is equal to V by R2. Current through resistor R3 is I3 is equal to V by R3. Let R be the equivalent resistance of each resistors connected in parallel. Thus, current across the battery I can be written as I is equal to voltage by R equivalent. Since in parallel connection, current across the battery is the sum of the individual current across the resistors, that is, I is equal to I1 plus I2 plus I3. On substituting the values of I, I1, I2 and I3 in equation, we get voltage by R equivalent is equal to V by R1 plus V by R2 plus V by R3. Taking V common in the right hand side, voltage by R equivalent is equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. Cancelling V on both sides, we get 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now, let us connect two resistors R1 and R2 in parallel. 1 by R equivalent is equal to 1 by R1 plus 1 by R2, that is equal to R1 plus R2 by R1 into R2. R equivalent is equal to R1 into R2 by R1 plus R2. It is observed that the equivalent resistance of parallel combination is less than the resistance of each of the resistors.